Hi, my name is Eric Foley. This is my lab 2. The goal of this lab was to compare the motion of an actual object to a computational model I made on Python based on the momentum principle to see if the momentum principle was a good predictor of motion. The main assumption we had to make during this lab was that the net force on the object was 0. And the video I used was of a can rolling across my floor that my roommate pushed while I taped it. This can, somebody rolls across the floor, and I scaled it on the left with the scaler to be about 12 centimeters long, so it comes out to 1.2 meters. And then, as you can see, as the object is rolling, I use the bottom middle of the can as the point to track. And I started it at the origin, and it's moving in the positive x direction. So then I stopped it once it was off the screen, and it started to slow down towards the end. So I got the data from that, and I put it onto Excel. Over here you can see this is the data from the video tracker software, and then I went to Python and I created my computational model, and I got the velocity of the object by taking the average velocity of the object in the video. So I took the final position minus the initial position, which was 0 because I started from the origin, and then I took the amount of time, which came out to about 1.04 seconds, and I divided the distance by that change in time, so that was the average velocity over the entire span. And since we're assuming there's no net force, it means the velocity shouldn't change. As you can see here, the velocity update depends on net force, and if net force is 0, that whole term is 0. So then the velocity stays the same all the way through. So using this, I created the model, the computational model, and with the same velocity running for the same amount of time, it should go the same distance. As you can see here, this is the ball going from the origin to a couple feet out, the same distance that the can traveled in my room. So I saved that data and I added it to the same Excel spreadsheet, and from there I went to the chart. I made a scatter plot of both of them. As you can see, the red line is the observation of the can rolling across the room, and the blue line is the model. The blue line is a perfectly straight line, assuming there's no change in velocity. So the x-axis is time in seconds, and the y-axis is distance in meters. So since the velocity of the ball in the model never changes, then it creates a perfectly straight line. Ideally, the velocity of the can wouldn't have changed either if the net force was truly 0. However, as we know, the friction from the ground and slows it down to some extent, so that's why the red line has a bit of a curve compared to the blue line, which is perfectly straight. The what if question is concerning my choice of axes and origin. As you can see, I set the can right at the origin to start with, so it would be easier to track along the x-axis, so it starts at x equals 0. And the positive x-axis is to the right. So this is reflected in my scatter plot because as time moves forward, the slope is positive because it's moving along the x-axis in the positive direction. If I had put the origin on the right and the x-axis going the other way, then the x-value should be going from a more negative position to a less negative position. So on the graph, this would be reflected by the same slope, but it would start farther negative and move towards the y-axis. We have to assume that there are no forces pushing, or the net force is 0, so any forces that are pushing are being pushed back equally. So obviously the can is being acted upon by gravity, however the floor is pushing back equally with the normal force, and we assume there's no forces from friction of the carpet or air resistance.